Welcome. Thank you so much for coming. Today's talk is entitled Mozart Could Have Been an Engineer. And today you're going to learn all about the parallels between music and code and why the brain of a musician might be similar to the brain of a software engineer. You're going to learn how we break down elements to learn in the same way, how we use patterns to build, how we use creativity to problem solve, and how we use persistence and flexibility to grow and succeed. And hopefully you'll walk away from this talk knowing that being a musician can mean that you can be a better coder, and being a better coder can mean that you can be a better musician. All right, so before we get started, I want a little audience participation moment. Raise your hand if you sing or play an instrument right now. That is amazing. That is so cool. Did you guys look around and see how many people raised their hand? It was mostly everybody. And you know what? I'm not that surprised because I am an opera singer turned software engineer. And when people hear that about me, they're like, oh yeah, there's lots of people in my company who are also musicians. And the more research I do into this, the more I find that that is the case. So who am I? My name is Meyers. If you want to tweet at me, was it like, oh, I forgot the glasses part. That was like my favorite part. I put glasses on Mozart. And I forgot to click to put, everyone take in the glasses, because yeah. Also, I had a designer help me Photoshop that. I couldn't even do it. So my name is Meyers, and if you want to tweet at me, I'm CC Meyers 324. Feel free to ask questions about this or give feedback or, be nice. If you want to email me, cmeyers@mavenlink.com. I am an opera singer turned software engineer, and I work at Mavenlink. And guys, we're hiring. So if you are looking for a job, you can go to mavenlink.com/careers or find me afterwards, or some of my coworkers are also here. Raise your hand if you're from Mavenlink. What? Yeah. Also, slides are located at bit.ly/music-code. So if you want to look at them later or anything like that, feel free to do so. So, music and code. There's been a lot of studies on music and the brain. The effects of music education on the brain, the effects of listening to music on the brain, the effects of musical training on the brain. They're from really impressive sounding publications. They have lots of medical jargon that I did not understand. And they do really cool things, like one that was studying jazz musicians figured out how to make a metal-free keyboard so that they could study the brain of a jazz pianist while he was in an MRI. I thought that was super cool. There's so much out there, and I was blown away by how much research had been done on this topic. So before we go in, I just want to nerd out a little bit. I've got some cold, hard fun facts. One of my favorite fun facts was this one, and it has to do with the brain's central sulcus. I have no idea if I'm pronouncing that correctly, but that is the part of the brain that determines whether or not you're right or left-handed. And physically, it will be more on the right side if you're right-handed and more on the left side if you're left-handed. And when they studied the brains of pianists specifically, they found that overwhelmingly, they had more symmetrical central sulcuses. Sulci? Sure. And since the pianist actually identified as right or left-handed for the most part, they concurred that actually this was not a natural symmetry. They weren't born with their central sulcus more symmetrical. It was achieved by all of their constant work making their weaker side as strong as their dominant side. Because if you're a pianist, you're using both right and left hands, they have to both be strong. And I thought this was so cool because it is an example of how you can physically change your brain with music education and musical training. The next fun fact just makes me feel good on a bad day. Learning to play an instrument is linked to a higher IQ. They did this with 2 groups, one of school-age kids and one of college-age adults. And the difference was definitely more dramatic in the kids, but still there in the adults. So you still have a chance. Even if you don't play an instrument now, start now. I mean, who knows? You could turn into Einstein or something. The next one is that music education is associated with enhanced ability to process speech and language. And you'll probably hear a lot about kids who learn music. You know, their brains are processing things faster, and they are developing faster. And specifically with speech and language, that's because when you're creating music, you're working the part of the brain that connects sound with meaning. And the last one is that IBM actually used to recruit music majors to hire as programmers. So one journalist found a really cool ad that IBM had put out in 1956. So this was the days before computer science was a major. And they were specifically looking for music majors to hire and to teach how to code. So why am I up here? Who am I? And why do I care about this? Well, I already told you that I'm an opera singer turned software engineer. And I might have a little bit of a different background than a lot of people in this room, or what people think of as the stereotypical software engineer. I didn't really grow up loving computers. It wasn't a thing I was passionate about. Maybe while like some of you were building computers and learning how to code as kids, I was wearing sequins and singing show tunes and giving you jazz hands. So this is me when, I don't know, like maybe second grade or so. And I was introduced to music in school, in public school. So can we give a little shout out here for public school music education, right? I can't say this enough that I would not be where I am today if I didn't have those teachers supporting me and helping me grow. I first started in general music classes, remember those like xylophones and metallophones, and moved on to the recorder, which my parents loved, and violin, piano. Then I begged for the piano lessons. That wasn't in school. And it was actually my 6th grade music teacher that first pulled my parents aside and said, hey, maybe you should give your kid voice lessons. She sounds like she might like this. So thank you to her. I don't even remember her name, but yeah, I started taking voice lessons, and that's when I fell in love with singing and fell in love with specifically classical music and opera. So much so that I decided to go to school for it. I went to Boston University and got my Bachelor of Music, and then I moved to New York and went to Manhattan School of Music, where I got my Master of Music. And then I was lucky enough to sing professionally for the entirety of my 20s. I got to do some really cool things and sing with some amazing people, and I loved it. The thrill of creating music, as I'm sure a lot of you know, is like nothing else. And it's incredible, especially when you can do it with hundreds of other people. But then I started nearing 30, and my priorities were shifting, and I was realizing that the life I was living wasn't actually making me happy. The instability of not knowing when your next gig was coming from was really getting me down. Working 5 jobs and still not being able to pay my rent, it was getting me down. And I realized that the industry and the reality of having a career for me was killing my love of music, and that's when I was like, I need to leave before I start hating music. I don't think that could actually ever happen. But so I decided to leave the industry and figure out what I wanted to be when I grow up. And after like a year of soul searching, I actually decided on coding. And I went to the Flatiron School in New York for their web development immersive program. Then I worked at an branding agency in Brooklyn and got some really cool websites to build called Red Antler. And then I decided I wanted to move to San Francisco, came out here and started working for MavenLink, or a project management software company. And there I was really able to go more full stack and love working there now. So opera singer turned software engineer. What in the world? Like, people just give me the funniest faces when they hear me say that. Did I see all those studies and be like, yeah, I'd probably rock at software engineering? Yeah, not at all. Like, it was a leap of faith. Literally, a friend was the first one to say, hey, have you thought of this? And I laughed in his face. I'm like, I'm an opera singer. Coding? But then after teaching myself some code, I really liked it. But I actually thought that my background wasn't going to help me at all. I didn't think I had any skills that were going to help me. I thought if I was going to be successful as a software engineer, it was going to be in spite of my background. And it wasn't until I started teaching myself more and more code that I realized that my background was actually helping me. So I want to start our adventure into the connection between music and code at the very beginning, at the learning process. So this here is a pretty simple song, and if you already know what it is, pat yourself on the back and thank your music education teacher. But if you don't know how to read music, you might be like, what the heck is going on here? I'm a little overwhelmed. There's lines, there's dots, and more lines, and symbols and numbers. What's going on? And you kind of just have to think back, when was the last time you learned a new programming language, right? How did you do that? You broke it down. So we're going to break it down now. Think about the first time you wrote a simple JavaScript function. How did you learn that? You broke it down. First, you learned the vocabulary. What in the world does var mean? Or for those like hip and with it kids, const or let. What does function mean? And then you have to break it down to the syntax, right? You have to know where all those freaking semicolons go. If you don't put in a bracket in the right place, you're going to break everything. So you just break it down, and you learn it like any other language. So in music, we break it down as well. First, you're going to learn how to know what notes to play or sing. For example, that first space there is an F. And then you go up. The second line is a G. And then an A, and a B, and a C. And all of a sudden, when you learn what spaces and what lines are what, you know how to read music. F, G, A, B, C, D, E, F. There you go, F major scale. Actually, I have no idea if that was in the key of F. I don't have perfect pitch. And then you learn that all those stems and whether or not the dots are filled in, that denotes rhythm, or how long are you going to hold that pitch for. So before, it was just one long line without any rhythm. Now it's going to be F, G, A, B, C, D, F. And now all of a sudden, you got rhythm. You could also put numbers to that scale. And I'll come back to the numbers part later, so remember that. All of a sudden, this is now 1, 2, 3, 4, 5, 6, 7, 8. And now we can go back to our song. And of course, with that short lesson, everyone knows how to read this, right? So now we know, let's pick the letter names, right? It starts on A. A, G, F, G, A, G, 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 A, C, C, right? Who knows what song this is? There we go. Mary had a little lamb. You guys basically are the same as Mozart now. You're so good. So once you learn the basics, then you can start learning some more of the complicated symbols, right? What's that? That's a rest. That's basically like a set timeout in JavaScript, right? Nothing's going to happen for a second. You've got this. This is a repeat symbol. You mean go back to the beginning, do it again. What's that like? Yeah, it's like a loop. And then you can start figuring how one piece, like our melody, is going to fit with other pieces, like our harmony. And we have to figure out how one piece fits with other pieces in code, right? So let's take this example of a React To-Do app. I totally just stole this from the React Redux example GitHub. So props to them. And so you see here we have one component. We have a to-do component. It's bringing up your LI, and it's got its on-click functions and its completed or not completed state. And if you've learned React, you know that that is one part that's going to fit together with other parts. This to-do component is actually the child of a parent component, the to-do list. And you're going to know how that state flows and how all of those different things fit together. And this brings me to patterns. This is my favorite thing to talk about when people ask, wait, what do you mean there's like similarities between music and code? Patterns. It is the simplest way that I can describe the biggest connection between music and code. And it's actually what kind of led to my aha moment of, oh, actually, yeah, there is a connection. I was sitting in class one day at Flatiron School, and I gotta say, I was kicking ass, okay? The teacher was like, how do we do this? And I was raising my hand. I was like, oh, you're going to open that file, and you're going to write that method there. Don't forget to open that file, because you're going to need a method there. You forgot a semicolon there. And I was doing really well, super proud of myself. And then the instructor stopped and was like, so, Catherine, why are we doing this? Like, what's going on behind the curtain to make all this work? And I didn't know. I had no clue. And I was like, why in the world did I know all of those answers? I could just spit it out, but I didn't really know what was going on. And I realized, oh, these are just patterns I'm memorizing. And musicians know patterns. Musicians are trained to recognize patterns, to memorize them, and to replicate them. And that's what I was doing. My brain was just like, oh, patterns, I got this. So I had to actually slow myself down and figure out what was going on behind those patterns. And I'm glad I did. So, what is this? Back to the simple JavaScript function. Where are the patterns? You've got patterns, especially in the syntax. You have to know that after you name your function, you've got those open parentheses, and you can send in an argument, close parentheses, and open bracket. Those are all patterns that you're learning. And the patterns can get more complicated in code, right? Like take a Redux architecture. You have to know the pattern of how all of that state and data is going to flow throughout. The components, some are parent, some are child. The components are going to dispatch actions to their reducers, which are going to update the store, which are going to then update the components again, blah, 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 blah. Those are all patterns, right? Knowing how your state is going to flow through your Redux architecture is going to give you patterns. So let's look at more complicated patterns in music. This is an excerpt from Handel's Messiah. Even if you don't think you know Handel's Messiah, you probably know Handel's Messiah. Hallelujah, hallelujah, right? Yeah, you know that. It's from Handel's Messiah. This is a soprano solo from that oratorio, and it might be a little overwhelming. It's a lot of notes there, right? They all look like they move really fast. So how in the world are we going to learn that? Are we going to be like, okay, so that first note is an F. Got it. Second note is a G. Got it. No, a musician is going to figure out the patterns. So we're going to focus right here on these two measures. And what are we going to do? We're going to break it down now. So I've rewritten those two measures. And a musician's going to take a look at this. And they're going to see that, oh, we're just outlining a triad here. What's a triad? Do you remember when we sang the scale of numbers? 1, 2, 3, 4, 5, 6, 7, 8. Well, if we take just 1, 3, 5, we've got a triad there. 1, 3, 5, 3, 1. Building blocks of music. Correction, Western music. If you're a musician, you know triads. And if you see this, oh, 5 and 3s and 1s all over the place. 5, 3, 5, 1, 3, 1. Oh, and we got some other notes that are just passing notes to make it, a little more interesting. 5, 3, 4, 5, 1, 3, 2, 1. Okay, I get that. That makes sense in my head. All right, well, look at the next one. Same exact pattern, but a step down. Okay, cool. Now I've got 2/3 of this recognized and memorized. Oh my goodness. Last part, same pattern, one step down. Of course, it's not completely as simple as this. you might have noticed that the first triad is minor, second is major, and the third is diminished. If you recognize that, give yourself a pat on the back and thank your music teacher. So also patterns can be more complicated when you're working with data models, right? You got a lot of information to process. This data model was from an app that myself and a couple other engineers worked on at Flatiron School. At the time, I thought it was like the most complicated thing ever. Oh my God, look at all of those models. And now working in the code base at Maven, I'm like, oh, that's nothing. But you guys know that you have a lot of information to process when you are coding at work, right? You know that if you write code one place, that could break code in 10 other places. You have to have a lot of balls in the air at the same time, really be aware of so many things so that you can make sure you're not writing code that breaks. Information processing. So you have a lot to keep track of, and I realized that my background in music had prepared me for that. So let's take a look at this score. This is my score that I used in a performance of La Bohème by Puccini. And the aria I was playing as you guys came in is actually this aria. And it's a lot going on. And if you're overwhelmed by this, just think of the first time that you looked at a huge code base. That was overwhelming too, right? Musicians have a lot to keep track of. We already know that we have to keep track of like the notes and the rhythm. You also have this part, which is a piano reduction of an orchestration. So this looks a lot more simple than the 10 lines that would actually make up the whole entire orchestration of this opera, because when you're singing this on stage, you have a whole entire orchestra. And if that oboe is a measure behind, you better not let that mess you up. This is an opera, so you also have words to keep track of. These words are in Italian. And not only do you have to know the text, you have to know the subtext. There's a moment here where Mimi sings, Vivo sola, soletta, which just means I live alone. That's not what she's really saying. She's saying, I live alone. Yeah. And because she's singing this to Rodolfo. And you also have to keep track of dynamics. That little PP means pianissimo. So you're going to have to sing this really quietly. You're going to have to keep track of tempo. Up here we've got andante molto sostenuto, which you have to know means moderately slow and very sustained. You have to know that this, do you see this less than sign? Yeah, it's not a less than sign in music. It's a crescendo. You're going to get louder and louder. So you have a lot to keep track of, right? But you're just breaking it down and you're keeping track of the smaller elements. And one thing that's cool about this is there's been research done about information processing in musicians. And it all has to do with the corpus callosum. So the corpus callosum is that little red part, and it is in the center of your brain connecting the right and left hemispheres. And a lot of people think that, oh, musicians, they're all right-brained, creativity only. But actually, musicians, when they're playing or singing music, use practically every part of the brain at once. And so this corpus callosum is what allows the messages to go back and forth between the right and left hemisphere. Musicians using every part of the brain, right? So that means a lot of messages need to get back and forth between the right and left hemisphere. And when you're doing that, when you're constantly using that, it's actually going to increase the volume and activity of the corpus callosum. So that means musicians have bigger corpus callosums. Callosumi? I don't know. I'm not going to stop pluralizing all of these things. And so what does a bigger corpus callosum mean outside of music? It means that you can problem solve more effectively, efficiently, and creatively, both in academic and social settings, because you can cross messages between the right and left hemisphere faster and through more diverse routes. Problem solving, We got to do that in code, right? All the time, every day, you're problem solving. And I think one of the coolest things about coding is that there's never just one way to problem solve. There are infinite ways to solve a problem. So many ways to get from point A to point B. It can be that way, or that way, or that way, or that way. And as a musician, you have this innate ability to not only problem solve faster, but think of those many different routes from point A to point B. So then you can be that coder that can be like, wait, project manager, I'm not quite ready to code this yet. I have to decide which way to take. And one great thing about problem solving as a musician as well, you learn to never, never, never give up. We know as coders we cannot give up on solving problems. If you've got a bug that you've been working on for hours, for days, and you want to throw your laptop out the window, we don't, right? Well, hopefully. Our bosses wouldn't be so, grand with that. But musicians can't give up either. They will sit in a practice room for hours going over the same measure over and over again until they get it right? Just the way you might go over that same function over and over again until you figure out where that bug is and why it is and how to fix it. And this is one of those characteristics of both musicians and coders that lends itself to life skills as well, right? I don't think anyone in here is going to be like, no, problem solving isn't good to have in real life, right? It's good. Not only does it help you make a better coder, but it makes you a better person. It makes you a better employee. It makes you a better collaborator. And it's also a characteristic of something we called a growth mindset. So the idea of a growth mindset versus a fixed mindset was introduced by Carol Dweck. And Carol Dweck is a professor of psychology at Stanford University. And she is famous for coming up with this concept. And it's the concept that if you have a fixed mindset, you think your abilities are fixed. You are more likely to give up and to stick to what you know. If you have a growth mindset, you know that you're capable of growing and improving. You actually love learning. You love challenges. You see feedback as constructive and not a failure. And I bet everyone in this room has a growth mindset. And that's because as a coder, you have to have a growth mindset because we are constantly learning. You guys know we have a new JavaScript framework every 10 seconds and a new JavaScript library like every 2 seconds. Could you imagine the state of JavaScript if everyone was like, no, that's a new thing. Don't want to learn it. Like, this conference wouldn't even exist today. React is the new hotness because people wanted to learn it, right? And that's something that you learn as a musician as well. As a musician, you are constantly learning. You are figuring out how to master your technique your whole entire professional life as a musician. Opera singers especially, because physically our vocal cords change slightly as we get older, forcing you to figure out how to deal with that. You're learning new music constantly. And so that is one thing that definitely was another life skill that helped me become the continuous learner that I needed to be as a coder. And that leads me to another life skill, which is collaboration. And I love this stock photo. It's like Dave Franco and yeah. So we know that nowadays we can't just sit in a corner with our headphones on, coding and not talking to anyone. Those days are quickly disappearing. As coders, more and more we're expected to communicate well, to collaborate well, to figure out how to work with a team, all right? And being a musician teaches you that so much. As a musician, you learn how to listen. You learn how to give and take, when to lead and when to follow. If you listen to a jazz improvisation going on, that is the best example of listening and communicating that I can think of in music. I'm taking a jazz solo, And I know when to take that. I know when to give it back. The person that's going to take the next solo has listened to your solo and knows how to create a new solo that is going to complement yours and knows when to give that up. It is constant communication that is happening without words. As a musician, you also learn how to deal with many different types of personalities. And some of the stereotypes that you hear about opera singers can be true. And if you've heard any stereotypes about conductors, definitely true. But you learn how to work with many different types of people who communicate in different ways. And that can only help you when you're figuring out how to work with the designers and the team lead and your product managers and your project managers. You're going to figure out how to best work with them and communicate with them. Because in the end, isn't the goal of a musician the same as the goal of a software engineer? We're working with a team to create a product that can be that can be enjoyed by a user. It's the same thing. In terms of a web application, your user is the person at the keyboard using it, and as a musician, your user is the audience. But you're working with a team to get there. So why does this matter? Why did I care enough to stand up here in front of a bunch of strangers and talk about this? And the first thing is, I don't want you to let untapped resources pass you by. I have a very different background from someone who grew up coding and went and got a computer science degree. You might have a resume on your desk if you're in a hiring position that looks like mine did. And I want you to see that for the benefit that it is. For all those reasons that my background makes me a better coder. Remember that next time you see a resume like that. Diverse backgrounds are an asset. I come to a problem in such a different way from that other software engineer who has that more stereotypical background, who comes at it from a different way from someone with another background. We're going to come at the same problem with different options in ways to solve it, and that can only be a good thing. It's going to make the solution that much better. I got to go back to this. Music education matters, especially in this political climate where they want to slash everything. Well, they've been slashing everything for years, but I had to make my testimony of the fact that I would not be where I am today if it weren't for public school music education. And I am a better coder because of that. And if you can donate to programs that help music education, go for it. If you can call your senators and your local government and support music education, please do it, because it matters. And lastly, as coders, don't be afraid to get back in there into music or get into it to begin with, because as we've seen here, it can make you a better coder. Just by saying, hey, you know what, I think I'm going to get back into piano. That can help you in your day job. That can help you learn to listen better, help you to learn to break problems down better, help your pattern recognition. And I think that's reason enough right then and there to get back into that music hobby that you had once. All right, well, it looks like I flew through that. Apparently I was talking really fast. But thank you guys so much for coming.